Good morning or good afternoon, everybody. This is Michael O'Brien. I'm a fire chief in the Brighton Area Fire Authority in Michigan and on the board of directors for the International Association of Fire Chiefs. And with me today is the chair of the Fire and Life Safety section, Andy King, who's a fire marshal in Franklin, Tennessee. And what you're going to see today is a continuation or part two. And in part one, we discussed a little bit more in detail of how we got here today. But really, this is a combination of efforts over the last couple of years between the Fire and Life Safety section and NEMA. And we have some great representatives, some very technical experts that not only have really helped the Fire and Life Safety section over the years, but have really helped us to advance the quality that our codes now reflect. One of the main reasons why we've really dived or have really worked on this project is we want to make sure that our responding crews, our engine company officers, our truck company officers, when they get to a fire alarm system, that they can be as much of an expert. And we know that the fire academy, we know that fire officer school doesn't always provide that in-depth ability for a company officer to troubleshoot a fire alarm system. So today we're going to dive into the introduction and the fire alarm system basics. With me is Richard Roberts with Honeywell, also with the NEMA task group, and Dan Finnegan, who also serves on the Fire and Life Safety section board with Siemens. So everybody, good afternoon.
Thank you, Chief O'Brien. This is Andy King, currently serving as your chair of the Fire and Life Safety section, representing about 1,300 members that are in the International Association of Fire Chiefs. Very pleased to be here on this webinar to explain more about fire alarm systems. And so our learning agenda objectives for the day are, first and foremost, the benefits of the fire alarm system. We want to know the basic components that are involved. And then we're going to, in this segment, get into the types of fire alarm systems. And basically there's three types: a conventional type, an addressable type, and then the newest, which is intelligent. At the end of this presentation, we'll have more questions and answers if anything's come up that we need to handle, and we hope that you'll continue the discussion offline.
Okay, thank you, Chief King. This is Richard Roberts. Thank you, everyone, for attending. So let's get into this presentation and look at the benefits of a fire alarm system. And a fire alarm system, it's a critical component of the building's fire protection program. And this is intended to obviously reduce property loss, injuries, and fatalities. Other fire protection systems could include automatic sprinkler systems and passive fire protection features such as fire doors or fire-resistant walls, ceilings, and ducts. And we're not going to get into that, but the primary function of a fire alarm system is to enhance occupant safety by providing for their safe evacuation or providing people with disabilities to get to an area of rescue during a fire. Another critical element of a fire alarm system is to notify the fire service in a timely manner so they can get to the building quickly and do what they need to do. And lastly, fire alarm systems are required in the model building and fire codes, as well as insurance underwriters and facility standards. Next slide. Now, fire alarm systems provide early detection of a fire as well as notifying building occupants and first responders. They enhance occupant safety, reduce property loss, and allow for business continuity and minimize owners' risk and liability. So basically, a properly designed, installed, and most importantly, maintained fire alarm system can reduce fire fatalities. Next slide. Now, even though today's fire alarm systems are very sophisticated and technologically advanced, the fire service and company officers should not be apprehensive about interacting with a fire alarm control unit during an alarm or trouble condition if they have a basic understanding of how these systems operate and their intended use. So needless to say, the picture on the screen is not one of your advanced fire alarm systems. Next slide. Okay, let's get into the basic components of a fire alarm system. And in its simplest form, it really consists of the following four basic parts. Number one is the control unit, which is really the brains of the fire alarm system. It receives and sends signals to input and output devices. Input devices, number two, they are called initiating devices, and they detect a fire and send signals to the fire alarm control unit, which determines if an alarm condition is needed and sends signals to the output devices. Now, number three, the output devices, they're called notification appliances, and obviously they provide occupant notification. And lastly, all fire alarm systems, they're required to have a a primary and secondary power supply to operate the system under normal conditions and during emergency situations. So now we're going to do a little deeper dive into these various components.
So, Richard, one of the things that a lot of company officers see is they'll get a building fire alarm when the area loses power. With this slide, you're kind of saying that's not normal, right?
You should get a trouble condition if there's loss of primary power, but you would not get an alarm condition.
So typically, I know in our jurisdiction, when our companies do get to this, right, there are times that for some reason the alarm system's maybe doing something it shouldn't be, but the secondary power should cover it. And if it doesn't, or activates the building alarm, that's a good time for that company officer to flag it to their fire marshal or something along those lines as well.
Absolutely. Absolutely. And I'll get into a little bit more about secondary power supplies, which I think is very, important. So, okay. Now let's do a little more discussion about the fire alarm control unit. And it's really the brains of the system. And the brains of a fire alarm control unit is the central processing unit, or the CPU. Sometimes it's referred to as the motherboard or the main board. And this CPU receives signals from the initiating devices or possibly other fire alarm control units or other types of systems. And it processes these signals to determine the required output function, such as activating the alarm notification appliances or triggering other building fire safety control functions, such as HVAC shutdown or elevator recall. Now, all this processing of the input and the output data really happens at very, very high speed. Next slide.
Richard, while we're on that topic about the fire alarm control unit, for a company officer, can you just speak as to what we should expect? We see a lock there, but as far as accessing the fire alarm control unit, there shouldn't be any problems getting into it, touching it, operating any of the controls. Is there any risk there to us or any danger of messing something up?
Obviously, you want to have a basic understanding of the operation of a fire alarm system and the displays, which I think we will get to in other segments. There is a silence button, an acknowledge button, and we will get into all of that stuff, but it's really, I think, difficult to mess something up. But obviously, you also need a key to get into the fire alarm control unit cabinet, and that's to prevent unwanted people from getting in there and messing around with it.
Great, thank you for clarifying that.
Sure. So, if you stop and think about it, fire alarm systems, they have to perform during normal conditions and also during emergency situations. For this reason, fire alarm systems are required to have at least two independent and reliable electrical power sources. Now, the primary power is usually supplied by the 120 volt AC that is supplied by the electric utility company. And then this voltage is transformed or stepped down to a lower 12 or 24 volt DC that actually operates all of the system input, output devices and controls. Next slide. So talking about the secondary power supply, it's usually supplied by batteries that are contained inside the control unit or in a separate battery cabinet. And they provide power for the operation of the system in the event that that there is primary power failure. Now, the secondary power, okay, it's required to have sufficient capacity to operate the system under a non-alarm condition for a minimum of 24 hours, okay? And then at the end of that period, operate all of the notification appliances, such as the horns, bells, or strobe lights for 5 minutes in alarm. So this secondary power is very robust. Okay, next slide. All right, fire alarm systems. All right, let's look at the input devices. Do a little deeper dive in here. And a fire alarm system is activated by initiating devices that act as inputs to the fire alarm control unit, and they are either manually or automatically activated. So let's take a closer look. Manual fire alarm activation is achieved through the use of a pull station that requires human intervention. So in its simplest form, the user activates the pull station by pulling down the handle on the pull station, which completes the circuit and locks the handle in the activated position, and it then sends an alarm signal to the fire alarm control unit. Now, after operation, the fire alarm pull station must be restored to the normal non-alarm position by using a special tool or key, and that is needed to reset the control unit. So initiating devices that are automatically activated, needless to say, require no human intervention, and they respond to a number of detectable physical changes that are associated or that are byproducts of a fire. So looking at smoke detectors, they detect visible or invisible particles of combustion, and particles of combustion is typically referred to as smoke. Now, looking at duct detectors, they detect the smoke or particles of combustion that is present in the air moving through HVAC ductwork. Now, these devices are designed to prevent smoke recirculation in certain areas of the building or spreading to the entire building. Now, looking at heat detectors, they respond to thermal energy. In other words, heat produced from the fire. And the detecting element within the heat detector will activate when it reaches a predetermined fixed temperature, or when a specified rate of temperature rise occurs. So if it's a slow moving temperature rise, the fixed temperature will take care of it. But if it's rising very quickly, it may activate before the predetermined or the set point. Now, water flow detectors or switches, they detect movement of water from an activated sprinkler head by a paddle device that's inside the sprinkler pipe. So obviously, if there is an alarm condition, the sprinkler head goes off, you want to be able to detect that water flow, send a signal to the control unit, which then notifies the fire department. Okay, next slide.
Richard, while we're
Yep.
on that topic, I think I would make a comment about pull stations is that we're seeing fewer and fewer of those that are required by code. And I think that's probably for several reasons. One, because of malicious falses, but then the fact that the prevalence of cell phones, and then we've also got so many other technologies, especially sprinklered buildings. And so I think the code is recognizing that. I didn't know if we would want to comment on that for company officers.
I think that there's not a significant reduction in the requirement to install these, but certainly, some jurisdictions, they're having problems with nuisance alarms, and, they may want to, eliminate them, and the code does have requirements, especially in K through 12 schools, if you want to eliminate or reduce pull stations. So the code does address, for certain occupancies, if they want to reduce the number or the placement of pull stations in a particular type of an occupancy.
Great, thank you.
Okay, now let's look at output devices or notification appliances. And they provide audible or visual or visible notification of an alarm condition to the building occupancies. Now, there are numerous types of alarm notification appliances. Number one, bells. They alert people by the hearing, by the sense of hearing. And really, they operate by causing a striker to contact a steel gong, and this produces a vibrating bell sound. Looking at horns, they are a notification appliance that alerts people by the sense of hearing. And they are required to produce a very distinctive temporal 3 pattern. So it's just not a constant alarm tone. It has a very distinctive 3 pattern tone. Looking at speakers, they provide voice messages instead of the audible only tone from horns. And, speakers allow for pre-recorded or live voice instructions to be sent to certain areas of a building or throughout an entire building. And they are very good at sending messages as conditions in a building could change. And then, of course, visible lights, typically referred to as strobes, they alert people by the sense of sight, and they notify the building occupant. And their primary purpose is to notify building occupants who may be deaf or hard of hearing. So if they can't hear the voice message or the horn, these visible lights, these strobe lights, alert people who are hard of hearing or deaf. And tactile. It's a notification appliance that alerts people by the sense of touch or vibration. A lot of times in hotel rooms, you could get people who are hard of hearing. They can request a bed shaker or some sort of a vibrating thing that will wake them up in the event of a fire. So at this time, I would like to turn it over to my colleague, Mr. Dan Finnegan, who also is with NEMA, Siemens, and he's also on the Fire and Life Safety Section board. So Dan, take it away.
Well, thank you very much, Richard. And that certainly was a great educational overview of a lot of important aspects of the fire alarm system. And for the balance of our webinar today, I'm going to walk us through kind of the big picture on the 3 different levels of identification that the control panels and or fire alarm systems have. And you see them here in front of you. The conventional concept we're going to explore, the addressable system, and then the intelligent system. Why don't we go to the next slide, Chief? So let's talk about the conventional fire alarm system. You're going to find that this is the one that's been around the longest. These panels have birth dates going back into the 1950s, maybe even a little bit sooner. It's the simplest type of control unit, as you see. And in today's world of code advancements that are taking place, you're also going to see that the code is actually limiting where a conventional fire alarm system is used, so that they have a place and they have a location in our buildings, but you're going to find them primarily in smaller systems, smaller buildings, and they're very frequently associated in buildings where we're just monitoring the fire sprinkler system. But they do have the same components that Richard was talking about in regards to power supply, a main control unit, and initiating and notification circuitry. So this is where those points that Richard talked about. Go ahead.
So Dan, these are the units, right? If I'm responding out, where we might see something that says zone pull stations, and there could be maybe 4 pull stations, or zone smoke detectors, and there's like 5 smoke, right? When you're saying conventional, that's what they're going to kind of see, right?
Exactly right. Yeah, I'm going to show you a slide coming up here, Chief, where we'll be able to diagram that for you exactly.
Great.
But that's conventional is zoned is another excellent way to put it. Why don't we We've just gone to the next slide here. Now, another part of the conventional system that's important for us to realize is that these things not only receive pull stations, smoke alarm notifications, and they make some noise with the horns or bells attached, but they also have additional relays installed within them that operate other parts of the building, such as elevator recall. And it could be for releasing doors, it could be releasing fire doors, it could be interconnecting to a security system to unlock certain aspects of the building. So it's important to realize that they do have these auxiliary functions, but as we're going to see in the next slide, what's really key to these is the input and output devices that are connected via dedicated circuits. And here we go, Chief. Here's a good diagram of a conventional system. And you see the panel here in near center bottom, but you see a blue line, which in essence is a pair of wires or a circuit or a zone for each group and type. Now, these things can be zoned on a by floor basis. You might walk into the building and it'll say first floor, period. But it might say also first floor smokes, or it could say first floor pull stations, or it might say duct detector in the roof area. So you can see how the different wiring configurations are aligning it here. And you can mix these up. You can set them up in different arrangements. But the fact of the matter is, on a pair of wires, you can connect up to sometimes as many as 30 devices on a pair of wires. And as your first responder, all you're going to know is that the fire is in that area or that zone, and you're going to have to search out to find out exactly where that initiating device is coming from. We'll come to the solution to that in a moment. Yep.
Okay. Yeah. So that makes sense, just how you kind of described it. So there could be a series of detectors or series of pull stations. So they'd have to look to see which one's activated, and that's how they could solve if it was.
Right.
Great.
And we know that that a smoke detector is activated because it'll have a solid light on it. A little LED will light up on that detector to say, I'm the one that activated. In the case of a manual pull station, as Richard mentioned, they have to be key reset. When you either pull down a lever or push down the pull station, it remains locked in that open position that will give you the visual indication that that has gone off. So we're at there. So now let's expand and go to what I consider is really the most important step for the first responder that the fire alarm industry has taken. And this actually came about in 1982 is when the first addressable fire alarm systems were introduced into the marketplace. And the key message here is now each device, detector, pull station, has a unique number or unique address that is going to be displayed to you when you enter into the building. They're going to use a term called signaling line circuit. That just means that's the pair of wires that all of these devices are going to be connected to. And that, each of these devices connected on a pair of wires, we could have some cases 30 to 60 on a pair. Some designs are allowing up to 250 or more devices on a pair of wires. That gets into some engineering stuff, which we're not going to try to touch on today, but a pair of wires can handle many, many addresses. Let's go to the next slide, Chief. So in addition to the devices that Richard was talking about, as far as manual pull stations, smoke detectors, duct detectors, all these things can be addressable devices and come in as a single address or a single point. But when it comes to looking at monitoring conventional devices, which probably the most common one is your water flow switch, your tamper switch on the OS&Y valve, and you could have some conventional smoke detectors in an application that you want to bring into that addressable fire alarm panel. Well, they have addressable modules, and you're going to see the module down here, this little stainless steel 4-inch by 4-inch device. These are usually located in a 1900 box, often have a white cover on them. Maybe we'll have some numbers like 20-04 on them. That's the address. But you'll see these all often associated next to the sprinkler water flow riser and the tamper switch area with the OS&Y valves. So this allows the ability to take something that's not intelligent or addressable and bring them into the fire alarm system through this SLC loop, accordingly. And here's another good picture we see on the next slide is we're now taking the dotted line represents a single pair of wires. You see it going through a smoke detector. Then it goes to this addressable module, which in this case is picking up a conventional smoke detector. It could also be the conventional water flow or tamper switch. You see that SLC or that pair of wires going through the building, another smoke pull station, another smoke, another addressable module. And the nice part is when you walk in the door and you look at that fire alarm panel, that display on the front of the panel is going to tell you that it's smoke detector 1-10 on the first floor in Chief O'Brien's office. You know, it's going to spell out exactly where that device is located. And that obviously is the biggest benefit for the first responder, certainly to determine where is the fire originating from. And as these things build in a real fire situation, you're actually going to be able to see the spread of fire through the building by watching how this different devices get activated through a building. So what's the balance between conventional and addressable systems? Here's a good little chart that kind of gives you just a general overview of how these things separate. Conventional is going to take more wires, as we pointed out. Certainly less wires, you can put everything on a pair of wires. History log, we're going to get into that in a minute on the intelligence side, but there's a history log on addressable. Voltage communications, analog communications, just different types of communications they go by. But the key one is the bottom line here. Reports by zone on conventional, reports by device on addressable. If you don't remember anything else on this, addressable should equal individual device reporting. Conventional gives me a zone or an area of the building in which I have to look for. Next slide.
Dan, you know, I think you bring up some good points because sometimes the fire service has to help the building owner, the fire alarm contractor play detective. Why are we getting false alarms? Why are we getting activation of systems?
Right.
And I think this is a great point of, you know, marking the zone, marking the device in their fire report. And that way, if we ever have to go back and play fire investigator, or figure out what is creating the false alarms, we have some kind of history. And I think, you know, you did a right, because it could be a zone or in the addressable, we could get it down to room 102. It's always the smoke detector in room 102, which can really help us troubleshoot if we're going down that road of a troubled system.
Yeah, exactly right.
Chief O'Brien and others on the call too, I think Dan mentioned about it spreading throughout the building and be able to monitor that. The importance of that in my mind is that when we respond, if we silence the alarm or acknowledge that device, when additional devices go off, we're going to get another signal. So if companies are having difficulty resetting, there still may be a problem, and that's a big warning sign to go back and check the building for more events that might be occurring. Is that a valid statement?
Yeah, Chief King, you brought up an extremely valid point. And when we get into how the inner workings of the control panel, what buttons to push, that'll be in a future webinar. But yeah, it's important to realize just because we silenced a system, if that fire is still active, you're going to get the thing reactivating and going into alarm again. So those are important points. So visualization, once again, on the difference between conventional and addressable. We've shown it here. Once again, pair of wires for each zone, each area of protection, different devices. We're down an addressable. We're able to take one pair of wires, loop everyone in the building together, and more importantly, you will have an exact location of that device when it's gone into alarm. Next. Along with the fact that we're addressable, we're entering into the world of the fact that there's going to be a software program required. Different levels of advancement are necessary in this, but the fact of the matter is, when a device goes off, that panel can be and needs to be programmed to tell the panel what to do. Do I sound all the horns? Do I sound only the horns on a certain floor? Do I trip the signal to the fire department? And as you can see here, do I activate elevator recall? Do I activate a smoke control? Do I ring by zone or just specific parts of the building? Do I unlock door locks? Do I get involved with cross zoning? Another form of detection that we'll get into later. So the advantage to these addressable systems is now you have a lot more flexibility, and you can curtail the system from a design application, which should make your mission in the first responder world that much more efficient and effective. Now we're going to touch on the third classification of systems, and this is the intelligent addressable system. I would have to say that probably the majority of systems going in today are of the intelligent nature, but by all means, there are still addressable only systems out there. Some very good ones, by the way. But I think the majority, especially in your larger buildings, you're going to find to be intelligent. What makes it intelligent? He says, not only is it still addressable, but now we're actually taking those smoke detectors specifically, and we're able to digest data that's coming from them by communicating with that device back to the control panel, going back and forth. We can determine whether or not that detector is getting dirty or getting close to needing to go into a false alarm. As some of you may know, there's a code requirement that all smoke detectors need to be tested and inspected every year. Along with that, there's requirements for sensitivity testing of all smoke detectors. An addressable system can do the sensitivity testing for the entire building's detectors right from the control panel. And they give the owner, they give yourself if you request it, and certainly the fire alarm technician, a printout of the status of every smoke detector in the building and letting them know if it's getting dirty or maybe it's wearing out and needs to be replaced. So it's just that sharing of technology that moves forward. They also have what they call drift compensation, which now these are detectors that are looking at an atmosphere and they're looking at a room and they're adjusting to the fact that now suddenly we may be doing some cooking in a space. We may be doing some kind of processing where the atmosphere and the level of air movement is different. These things will self-adjust to that. They're often network compatible. So once again, larger systems. And from the first responder perspective, you know, when a trouble does occur, which could be, like Richard pointed out, the loss of AC power, but could also be if somebody removes a detector. If you take that detector down from the ceiling, you're going to get a trouble condition. If you remove a pull station or knock a pull station off the wall with a baseball bat, you're going to get a trouble condition. And this is going to be able to pinpoint where that trouble is coming from. Conventional systems will tell you you'll have a problem in the building for the most part. An addressable intelligence system will let you know that you have a problem on this pair of wires, probably in this location, in either one or two or three different offices. So rapid and direct identification of the fire threat is what we've already touched upon, and that is it's just giving you more and more information. Some of your larger systems that you'll see when we get involved in that is you'll actually maybe have a graphical screen that'll show you exactly where that fire is at in a building, but you won't see those on most systems. Next slide.
Hey, Dan.
Sir.
Yeah, this is Richard. These intelligent systems and intelligent detectors, you may want to talk a little bit about adjusting the sensitivity to make it more sensitive or less sensitive. Obviously, it's within certain criteria, but that could help reduce unwanted alarms.
Yeah, it's a very good point, Richard. And generally, this is caught in the design stage. But if you, as the first responder, are coming in and you're getting a case of smoke detectors going off when nothing really serious is going on, you should definitely ask your building owner to have his fire alarm company take a look and see if they can adjust the sensitivity. There is a window of adjustment that's allowed to make the detector a little more sensitive or to slow it back down. All manufacturers have some level of programming that they can do to do that. So it's a good step to take and to avoid any unwanted alarm situations as we go forward. So learning and recap, in addition to everything that Richard has shared with you on the devices, you know, we've touched on what the benefits of the fire alarm system are. Clearly, it's there 24 hours a day, 7 days a week to notify the building occupants of an emergency, give early warning, to notify the fire department and bring them in to get their job done. The fire alarm system basics, you got a very good overview of the concept of the devices you're going to be touching. And we just went through the different types of systems. But as you continue through this webinar series, we commit to you to be drilling down a little bit deeper, you know, and I know Chief O'Brien brought up that one very valid point of when you open the door or walk up to that panel, what do the lights mean and what do the buttons mean? That information will be following shortly in some future webinars, because that I found to be the key thing. We want you to be very comfortable and to be very accurate in what you're doing with these systems, and hopefully working together with you to save as many lives as possible. Chief O'Brien and Chief King, that's all I have to say. Thank you.
Yep.
Thanks, Dan. Thanks, Richard. We would love to answer your questions in future webinars. You can find us on the major social media platforms. You can find the Fire and Life Safety section on Facebook, Twitter, and Instagram. You can hit us up with a message or a comment, and we'd love to get your feedback. And even when we post these, we'd love for you to throw some questions in the comments, and we'll try to do our best. Andy, some parting words.
No, I think it was a great webinar, and it brings up a lot of good points for discussions. You know, all of us have different experience with alarms, and I think what I recognize over time is that things are getting better and better. And even commenting on intelligent systems is that removing a single device sometimes is the better option than going back for repeated false alarms when you're evacuating a building, causing multiple fire department responses, and so on. And so those are the overall benefits that we're seeing, not only to the fire service, but to the public. And at the end of the day, that's really what it's all about.
Yeah, the technology that's out there is pretty incredible as to what these systems can do nowadays. So Andy, Richard, Dan, thanks again for your time. Hope everybody has a great week. We'll talk to you next week.